Hi, meet you again. Today we are going to learn direct variation 1.1c, the relation between three or more variables for a given joint variation. What is the relation between three or more variables for a given joint variation? Today, our learning standard is to determine the relation between three or more variables for a given joint variation. Let's do this activity. In this activity, we would like to determine the relation between three variables for a joint variation. In the diagram on the right shows a rectangle with x centimeter in length and z centimeter in width. It is given that the area of the rectangle is y centimeter square. Complete the table below. Discussion. What is the relation between y and x if z is a constant? What is the relation between y and z if x is a constant? What is the relation between y, x, and z if three of them are variables? In general, for a joint variation, y varies jointly as x to the power of m and z to the power of n can be written as y alpha x to the power of m z to the power of n. This is written for the variation relation, whereas y equal to kx to the power of m, z to the power of n for the equation form. Now, let's do example 9. Write the relation using the symbol alpha and in equation form for each of the following. Solution. A. P varies directly as q and square root of r. B. Y varies directly as the square of w and the cube of x. C. The volume of a prism V varies directly as the area of cross-section A and its height h. D. The mass W of a cylindrical metal rod varies directly as its length P and the square of the diameter of its base D. Example 10. Given that x alpha y square z express x in terms of y and z if x is equal to 6 when y is equal to 3 and z is equal to 5. Solution. X alpha y square z is written as the variation relation, whereas x is equal to ky square z is written as the mass equation. Substitute the value of x with 6, substitute the value of y with 3, and substitute the value of z with 5. After we do the calculation on k, we will gain k is equal to 2/15. Hence, x is equal to 2 over 15 y square z. Example 11. The gravitational potential energy E joules of an object varies directly as its mass m kilogram, the gravitational acceleration g meter per second square, and its position at a height of h meter from the ground. Given that E is equal to 197 joules when m is equal to 4 kilogram, g is equal to 9.81 meter per second square, and h is equal to 5 meter. Write an equation that relates E, m, g, and h. Solution. Write the variation relation as E alpha mgh. Now, write the relation in the form of equation as E equal to k mgh. Substitute the values of E, m, g, and h into the equation to obtain the value of k. Since that we gain k value is 1, hence E is equal to mgh. Example 12. Three quantities S, T, and U vary as shown in the table on the right. It is given that S varies directly as T and the cube root of U. Calculate the values of X and Y. Solution. Write the variation relation as S alpha T cube root of U. Then, write the maths equation as S equal to k T cube root of U. Substitute the value of S, T, and U. You may find that the value of k is 2.5. 2.5 T cube root of U. By using the formula that we gained just now, let's find the value of X when T and U is given. After the calculation, you may gain X is equal to 15. Now let's find the value of Y. By using the same formula, when S is equal to 50 and T is equal to 40, substitute them into the equation. Then, you gain the value of Y as 0.125. To check your understanding, please do the self-practice 1.1c from number 1 to number 8. Good luck! Thank you. Don't forget to like, share, and subscribe to this channel. Bye-bye. See you again.